Hello students, welcome to a new math session. Today we'll be talking about solving inequality in first degree of one variable. Let's now go and check the properties of the inequality. If a, b, and c are three real numbers, if a is greater than b, then automatically a plus c will be greater than b plus c, but c is a non-zero real number. Then a minus c is greater than b minus c if c is greater than 0, where a minus c will be less than b minus c if c is a negative number or c is less than 0. Kindly note that when we multiply or divide both sides of the inequality by a negative number, we should change the symbol of the inequality. Exercise 1. Find the solution set of the inequality in R and represent the solution in the number line. 2x minus 1 is greater than or equal to 5. Then the 1 will be moved to the other side as a plus 1. So 2x is greater than or equal to 5 plus 1. Then 2x is greater than or equal to 6. We divide both sides by 2. So x is greater than or equal to 3. So the solution set is an interval starting from 3 closed until infinity opened. We can easily represent this on a number line as we explained in the previous session. So it will start from 3 closed going up to the right hand side until it reaches positive infinity. Exercise 2. Find the solution set of the inequality in R and represent the solution in the number line. 5 minus 3x is greater than 11. So the first thing we do is that we move the 5 to the other side with a minus, so it will be negative 3x is greater than 11 minus 5. So negative 3x is greater than 6. Now we're going to divide both sides by negative 3. Remember the note when we said if you divide both sides of the inequality by a negative number, we should change the symbol of the inequality. So here we're going to divide both sides by negative 3. So x will be less than negative 2. Take care, it was greater than, now it is less than. So the solution set is an interval that starts from negative infinity opened until negative 2 also opened. How can we represent this on a number line? Here's the number line from negative 2 opened going left until it reaches the negative infinity. Exercise 3. Find the solution set of the inequality in R and represent the solution in the number line. Negative 3 is less than or equal to 2x minus 1, and this is less than 5. In order to make x alone in the middle, whatever you move from the middle, we move it to both sides. So here, minus 1 will be moved as a plus 1 to both sides, to this side and also to this side. So it will be minus 3 plus 1 less than or equal to 2x less than 5 plus 1. So it's negative 2 less than or equal to 2x less than 6. As we said, whatever we do in the middle, we have to do on both sides. So in the middle you have 2x, you're going to divide it by 2. So on the right hand side you divide it by 2, and the left hand side you also divide it by 2. And remember, if you divide by a negative number, you have to change the inequality symbol. But here we're going to divide by 2, which is a positive number, so there's no need to change the inequality symbol. So here we divide by 2 here, we divide by 2 here, and we divide by 2 here. As you can see, it will be negative 1 less than or equal to x less than 3. So the solution set is an interval that starts from -1 closed going until 3 opened. We can easily represent this on a number line from -1 closed until 3 opened. Exercise 4. Find the solution set of the inequality in R and represent the solution in the number line. 2x minus 3 is less than or equal to 3x minus 1 is less than 2x plus 2. Here you have x in the three parts of the inequality. We want x to be in the middle, so we're going to add negative 2x to all the sides of the inequality. As we said, by adding negative 2x to both sides of the inequality, you will have it as 2x minus 3, 3 minus 2x minus 1, 2x minus 2x plus 2. 2x minus 2x in each of the left side and the right side will be crossed out together, so it's negative 3. And then this negative 1 will move it to both sides as a plus 1. So it will be negative 3 plus 1 less than or equal to x less than 2 plus 1. So the inequality now is negative 2 less than or equal to x less than 3. The solution set in here is an interval that starts from negative 2 closed until 3 opened. We can easily represent this on a number line from negative 2 closed until 3 opened. Let's now go and start the evaluation. Pause the video, answer the questions, play the video again, and check your answers. Let's see how can we go and solve the evaluation part. Question 1 is asking me to complete. A, if 5x is less than 15, then x is what? We're going to divide here by 5, divide here by 5, so easily x is less than 3. Question B, if x minus 3 is greater than or equal to 4, we move this to here as a plus 3, then x is greater than or equal to 4 plus 3, which is 7. Here, in question C, if negative 2x is less than or equal to 3, we're going to divide by negative 2 in both sides. Then if you divide by a negative number, you have to change the inequality sign. Then x is greater than or equal negative 3 over 2. Question D, 1 minus x is greater than 4. So if you move the 1 to the other side, it will be minus x is greater than 4 minus 1. Then minus x is greater than 3. If you divide both sides by negative 1, then x will be greater than negative 3. We change the inequality sign because we divided by a negative 1. Question E, we're going to divide both sides by square root of 2. So x is less than or equal 4 over root 2. Rationalize the denominator by multiplying both sides up and down by square root of 2. So 4 root 2 over 2. Then x is less than or equal to square root of 2. So here x is less than or equal to square root of 2. Question 2. Find the solution set of the inequality in R and represent the solution in a number line. Let's go to question A. We have 3x minus 1 is less than 5. We move the 1 here as a plus 1. So it's 3x less than 6 divided by 3 divided by 3. Then x is less than 2. The solution set is an interval that starts from negative infinity until 2 opened. For the number line, here's the number line from 2 opened all the way towards the negative infinity. Question B, 2x plus 5 is greater than or equal to 3, then 2x is greater than 3 minus 5, so 2x is greater than or equal to negative 2 divided by 2 divided by 2. then x is greater than or equal -1. The solution set starts from -1 closed all the way until positive infinity opened, where the number line from -1 closed to the positive infinity. Question C, 2x plus 3 is less than or equal to 1. As we did in the previous one, 2x is less than or equal 1 minus 3. Then 2x is less than or equal to -2 divided by 2 divided by 2. So x is less than or equal -1. The solution set is an interval that starts from -infinity opened all the way to -1 closed. For the number line, here is the -1 closed, and it's going towards the -infinity. Question D, 5 minus x is greater than 3. If you move the 5 to here, then -x is greater than 3 minus 5. So -x is greater than -2. If you divide by -1, don't forget to switch the inequality sign. So it's less than 2. So the solution set is an open -infinity until 2 opened, where the number line is from 2 opened all the way towards the -infinity. Now, dear students, we came to the end of our session. Thank you very much and wishing you best of luck.